This is the second part of our lecture video about basic concepts of probability. And in our next example here, we are assuming that boys and girls are equally likely, and we want to find the probability of getting 3 children all of the same gender when 3 children are born. So there are 2 different ways that you can approach this probability. The first one is to look at your sample space. And we had this sample space written out earlier, so it's boy, 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 girl, boy, girl, boy, girl, boy, 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 girl, 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 boy, girl, and girl, girl, boy, and the last one is girl, girl, girl. So you can list out the sample space and then count how many events there are where all of the children have the same gender. And there are 2 events where all of the children have the same gender, boy, 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 and girl, girl, girl. And so then the probability of all same gender is equal to 2. That's the number of events in the sample space that have all the same gender, divided by the total number of events in the sample space. So that would be equal to 2/8, and that simplifies down to 1/4. The other way to think about this is to multiply the probability of each birth. And so the probability that they will have, if you know that they're going to have 3 children, the probability that they have a first child, could be a boy or a girl, just the probability that they're going to have a child is 1. And then the probability that, because this could be a boy or a girl, it doesn't matter, that's why the probability is 1. But now the next one has to match the gender of the first child born, and so the probability that the second child born will be the same as the probability, or the same gender of the first child is 1/2. So if this one was if the first child was a boy, then the probability that the second one would be a boy is 1/2. Same with if the probability of, or if the first child was a girl, then the probability that the second child would be a girl is also 1/2. And the third one, so we're going to just assume that these are all boys. So the probability that the first child will be either a boy or a girl is 1. The probability that child 2 is going to match the first child's gender, now let's just pretend that it was a boy. The probability of child 2 being a boy is 1/2. And the probability of child 3 being a boy is also 1/2. And so 1 times 1/2 times 1/2 is 1/4. So our probabilities are the same, either way we decide to do it. And it doesn't matter to me which of the 2 ways you do. Whichever way is easiest for you works for me as well. In our next example, a study of U.S. paper currency, bills from 17 large cities were analyzed for their presence of cocaine. Here are the results. 23 of the bills were not tainted by cocaine, and 211 were tainted by cocaine. Based on these results, if a bill is randomly selected, find the probability that it is tainted by cocaine. First, we need to calculate the total number of bills. So there were 23 bills that were not tainted, plus there were 211 that were. So the total number of bills was 234. We want to calculate the probability that the bill was tainted. And so this is the 211 bills that were tainted divided by the total number of bills, 234. And if we compute this number on our calculators, 211 divided by 234, we get 0.9017, but we want 3 significant digits, so that means in this case 3 decimal places, because there's no zeros between the decimal point and our first non-zero digit, so we would want to round that 17 up to 2. In our next example, if a year is selected at random, find the probability that Thanksgiving Day in the U.S. will be on Wednesday. So, in the U.S., Thanksgiving is always on Thursday. And so the probability that Thanksgiving will occur on a Wednesday, it never will. And so that probability would be 0. It is fine to have a probability that's 0. We just can't have probabilities that are negative. The probability that Thanksgiving will be on a Thursday would be equal to 1. Thanksgiving in the U.S. is always on a Thursday. So again, we can have probabilities that are equal to 0 and that are equal to 1. We can't have probabilities that are negative, and we can't have probabilities that are larger than 1. Next, a definition. So a complement. This consists of all outcomes in which event A does not occur. So this is basically, it's like the opposite of some event A is what the complement is. Oh, and the notation for a complement is to put a line above it. So basically it's saying that it is not, it's like saying not A, it's the opposite of A. So in our next example, a recent Harris Interactive survey of 1,010 adults in the U.S. showed that 202 of them smoke. Find the probability that a randomly selected adult in the U.S. is not a smoker. So earlier we calculated the probability of a person being a smoker. Now we want not a smoker. So first we would need the number of people that don't smoke. So that's the total number of people, 1,010, minus the number of people that do smoke. So 1,010 minus 202, and we get 808. So we want the probability of not a smoker. And that's going to be, 808 divided by 1,010. And that would be 0.8. So you could compute this probability in a different way, and that's knowing that there are only two types of people in this case. There are going to be people who do smoke and people who do not smoke. And so that includes everybody, and so the probability that you would either be a smoker or a non-smoker is 1. And so we can compute the probability of not being a smoker as 1 minus the probability of being a smoker. So that would be 1 minus 0.2. This was a calculation that we did in an example earlier, and that also gives us 0.8. So again, both of these ways are appropriate, and a lot of times when we're doing these probabilities, we will do the 1 minus a probability. Just a few little notes. An unlikely event is a probability, excuse me. A couple of little notes. Something that's unlikely has a probability that's very small, such as 0.05 or less. And so this is sort of a diagram of things. So these are the probabilities. Oops. And these are whether they're likely or not. And so this would be a probability of 0.95 right here. This is not a scale picture. And this would be 0.05. So this is a probability that something will not happen. It's impossible. And up to unlikely, which is 0.05, a probability of 0.05. And then a 50-50 chance is, of course, a probability that it will happen half the time. And then up to 0.95, we would consider that likely. And then, of course, probability of 1 is something that will always happen. So the probability of an event is a fraction or a decimal number that's between 0 and 1 inclusive. So inclusive means that it includes 0 and 1. The probability of an impossible event is 0, and the probability of an event that is certain to occur is 1. So that was like the example of about Thanksgiving Day. So Thanksgiving is always on Thursdays in the U.S., so the probability that Thanksgiving would be on a Wednesday is 0. Probability that Thanksgiving would be on a Thursday is 1. Some notation. The probability of event A is denoted as P of A, which we've looked at already. The probability that event A does not occur is denoted by the probability of the complement of A. So remember, this is the complement of A. Right. In our next example, when a fair coin is tossed 1,000 times, the result consists of exactly 500 heads. The probability of getting exactly 500 heads in 1,000 tosses is 0.0252. Is this result unlikely? So let's stop there and answer that question. So is it unlikely? And so now this probability seems weird, but the chance that you're going to get exactly 500 is that probability is 0.0252, and we'll take a look at why that's as low as it is in chapter 5, I believe it is. It's either 5 or 6. I think it's 5. So this is very low, and 0.0252 is less than 0.05. So this is unlikely. And then next it says, is this result unlikely? And the answer is, it is unlikely. And then, is 500 heads unusually low or unusually high? And even though this probability is low, we would expect about 500 heads. So remember what we expect, and something's probability of occurring can be different things. So don't get those two confused. And our last example here, when a fair coin is tossed 1,000 times, the result consists of 10 heads. Is this result unlikely? So just because 10 is so low compared to how many we would expect, so we would expect about 500, we can say that this is unlikely. Is 10 heads unusually low or unusually high? And it's unusually low. So we would expect about 500, and so 10 would be an unusually low number. So that is it for the basic concepts of probability. I hope you guys are having a wonderful day,